Hi everyone, and this time we'll be talking about couples. No, I'm not asking to give you advice about relationships. No, this is something called a couple moment, and what it is simply it's two forces acting in equal and opposite directions that are going around a particular point. They're parallel, they're in opposite directions, and they are centered on some particular point. A great example of this is your driving wheel. Okay, you're driving down the road. When you're turning your driving wheel, we're driving wheel. Oh, lots of notice, folks. There we go. Okay, driving wheel. And when you turn it, you don't typically, grab it like this. You don't pull down with both hands to try to turn it. You don't pull up with both hands to try to turn it. No, if you're turning your driving wheel and you're doing it like you're supposed to, you use both hands and you turn it in opposite directions. The reason for this is because all this does is cause it to turn. It doesn't try to move the center of this to the left or to the right, up or down. I do notice I did those in the wrong order. No, it only tries to make it turn. So when two forces act in equal and opposite directions, they're centered on some particular point, then they don't cause translation at that point. They don't try to move it in any direction. All they try to do is turn things around that point. Okay? So if I want to figure out what the moment is due to these forces, I figure out the distance between them, that perpendicular distance, and I multiply it by one of their forces. So the moment will be equal to force times distance. If I really wanted to, I'm going to do it from the center. I could also do is equal to 2 times the force d over 2, which just comes up to be the same exact thing. Just remember, it's a line of action of the forces and it needs to be perpendicular. The moment of the couple is independent of the choice of the axis of moments. Couple moments are free vectors, which means that it doesn't matter where you were taking your moment earlier. Like let's say you had this long beam and you had, you were taking moments around this point, and you found out you have a couple moment applied over here. You can move that anywhere you want, and so you'll have to move it over to that point when you sum moments. Just has to stay in the same plane. Magnitude of a resultant force is 0. They only cause rotations, not translations. And if a force system is composed only of couples, the resultant moment will consist of another couple, and we just add all those moments, or all those moment couples together. Just like we did with our parallelogram method or our components method, we can add all those moments together in very similar fashion. The only way to balance a couple is to have an equal and opposite couple in the same plane. Just like every force needs an equal and opposite force to balance it. And finally, a couple is fully defined by its magnitude and sense of direction. All you need to know is it clockwise, is it counterclockwise, and how big is it? Because it's a free vector, it can move wherever it wants. Okay, so that is it for couples. I know this doesn't tell you too much. You need to see some examples of it. So please go check out the example problems, and I will see you all later. Have a wonderful day. Bye-bye.